Okay, so we're looking for two consecutive positive integers multiplied to give you 72. Two consecutive positive integers multiplied to give you 72. What are those two numbers? Okay, now let's go over the idea of consecutive integers. Well, let's say we have consecutive integers. So they're just integers. Integers would be things like, well, whole numbers would be things like 1, 2, 3, or counting numbers. Counting numbers would be like 1, 2, 3. Whole numbers would include the 0. Integers include things like -1, -2, -3, dot, 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 right? So there's an infinite number of counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. Whole numbers, infinite number, you just include the extra of the 0. That's included in the whole numbers. Integers, they include 0, all the counting numbers, plus they include all the negative numbers, -1, -2, -3, -4, that are kind of negative whole numbers to kind of not use the terminology correctly, right? But they're just kind of the mirror images of the counting numbers, right? So instead of positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that includes -1, 2, 3, -2, -3, -4, -5, -6, -7, so on and so forth. So those are the integers, right? Notice that you don't see any repeating decimals, you don't see any fractions, you don't see anything like that, right? So these are integers. Now, they want two consecutive positive. So first of all, they're going to be consecutive, and then they're going to be positive. Okay, now that's important. So for instance, if we had 1, 2, 3, those are consecutive positive integers, right? Now, how do we generalize this pattern? Well, for instance, if we say the first one is x, if we just say arbitrarily whatever first integer we're talking about, positive integer we're talking about, we're saying that's x. Well, the second one would be one more than that, right? The difference between these, let me illustrate this a little bit better. So we would say there's 1. The difference between 1 and 2 is +1. And then, well, how do we go from 2 to 3? Well, the difference between 2 and 3 is +1. So what we would basically say is, whatever the previous one is, the next one is that number +1. And the next one would be that previous number, right? Which was x plus 1 plus 1. And you'd simplify that to simply x plus 2. So basically it's x plus 1, x plus 2, x plus 3, x plus 4, x plus 5. That's how you would generalize this pattern of 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. Okay, now, that's important because we say two consecutive integers. So let's say we say the first integer. Let's say we say the first integer is an x. Well, then we could say the second integer is going to be what? The next consecutive integer is just going to be that plus 1, or x plus 1. Okay, now what they said is when you multiply these together, that gives you a 72. Well, that's simply x multiplied by x plus 1 equals 72. Okay, now this is a quadratic, but we haven't multiplied the x's through yet. So let's distribute the x and make it look more like a regular kind of quadratic. So x times x is x squared. X times 1 is 1x, or just x, equal to 72. Let's say we want to solve this. And if we want to solve it using the zero factor property, the first step is to set it equal to 0. In which case we need to subtract 72 from both sides. 72, 72, cancel, cancel. So we end up with x squared plus x, minus 72 equals 0. Now, if we're solving the quadratic equation using the zero factor property, first step is to set equals 0. Second step is to factor it. Okay, so we are going to factor it. Okay, so square root of x squared is x. It ends in a negative, means they're going to have opposite signs. It ends in a negative 72, right? Negative 72, which means it's going to have opposite signs. We're looking at two numbers that multiply together give you a negative 72. If we add together, it would give you a positive 1, which is the middle coefficient. I know the stronger number has to be a positive. If I add a negative and a positive together and I get a positive, the positive was stronger. If I add a negative and a positive together and I get a negative, the negative was stronger. Okay, so you could do some numbers here. So 1 and 72, 2 and 36, 3 and 24, 4 and 18. And we could have a 6 and a 12, and we could have an 8 and a 9. Okay, and because it ends, it has to be, the positive has to be stronger. All the numbers on the right are positive, and all the numbers on the left are negative. Okay, so those are all the combinations of numbers that we can multiply. Well, not all of them, but combinations of numbers that we can multiply together to give a negative 72. Now let's see what happens when we add them together. Now, the only one that will give us what we want is the last one, which gives me a positive 1, right? So two numbers that I can multiply together to give you a negative 72, but if I add together, I get a positive 1, and that is in fact a negative 8 and positive 9. Now, since that's a negative 8, you do have to put that next to the subtraction, and since that is a positive 9, you do have to put that next to the x there. Okay, so whenever we're solving a quadratic using zero-factor property, first step is to set it equal to 0, check. Next step is to factor everything, check. Next step is to set the factors equal to 0, and let us do that. And then we solve it, right? So we say minus 9 plus 8 plus 8. I'm jumping around a little bit, my bad. So that gives me a negative 9 there, and that gives me a positive 8 there. You could have just looked at there and said, well, x plus 9 is equal to 0, therefore x is equal to negative 9. That would have been true. Or x minus 8 is equal to 0, therefore x is equal to positive 8. That's true. Just realize they're not always going to give you nice numbers like this in the parentheses. Sometimes it's going to be a coefficient other than 1 in front of the x. These can be fractions, so they can get ugly. So it's still nice to remember that you're kind of setting them equal to 0 and solving, even though most of the time you can just do it mentally. So you still kind of want to probably know about that. Now, what are those numbers? Oh, we got two numbers, right? So you might be tempted to say, well, the numbers are negative 9 and 8. But there's a problem with that. It said positive integers. Well, this negative 9 here, that is not a positive integer. Negative 9 is a negative integer, right? So we know right off the bat that is not a valid answer. Oh, but you might say, oh, I only have one answer. Well, that's true, but x is your first integer. Your consecutive or next integer is plus 1, or in this case, it's going to be a 9, right? A plus 1, which gives us a 9. So your two consecutive positive integers are going to be an 8 and a 9. So again, I realize it might be very tempting once you get the x is equal to negative 9 and x is equal to 8 to say that, oh, those must be my two answers, but those are not your two answers. You have to go back and reread the problem, the word problem, and make sure that you're answering what they're asking for. So you throw out the negative 9, you keep the 8. That's only half of your answer, though. You have to add 1 to it, get your second answer of the 9. So your first integer is an 8, your second integer is a 9. So your two consecutive positive integers are going to be an 8 and a 9. Okay, so simplify the expression in standard form for a plus b. All right, fair enough, we can do that. So what we want to do here is we want to say that, so a plus b is, this is kind of the real part, and this would be the imaginary part of a complex number. And it's written in standard form in that order. So if you write a complex number in standard form, it's going to have the kind of the real part first, and it's going to have the imaginary part second. So we're going to combine forms of the constants, right? So this is really saying 5 minus 2, and 5 minus 2 is in fact a 3, and then you're saying negative 3 minus a positive I. Now, if you find this confusing, what you could do is you could distribute it. If you're good with signs, don't worry about this extra step, but if you find yourself making sign errors, then you might want to distribute this negative inside those parentheses, like that. So you say negative 1 times 2 is negative 2, negative 1 times positive I is negative I, and then only after that you want to combine like terms of 5 minus 2, which give you a 3, and then you say negative 3I minus I with an implied coefficient of, minus 1 there, right? And then you say negative 3I minus 1I would give me a negative 4I. Okay, and you have the A part, which is the 3 in this case, first, and then you have the BI part, which is kind of the imaginary component, which is after their minus 4I. So this is in fact in standard form. Complex number in standard form. Okay, let's try the next one. Okay, so we're going to distribute this. So we're going to say 7 times 3, so far so good, 21. 7 times 4i, you're going to kind of treat the I at this point as a variable, as if it was an x, y, z, a, b, c, just as a variable at this point. So you're going to say 7 times 4 is a 28, and you're going to just bring along the I. You're going to say negative 2i times 3 is a negative 6i, and then you're going to say negative 2i times positive 4i, negative 2 times positive 4 is a negative 8, I times I is I squared. And this is the point where you need to remember that if I is equal to the square root of negative 1, then that means I squared is equal to kind of to the square root of negative 1 squared, or just negative 1. Kind of that logic, right? So, but the point here is that when you square the I, you actually end up with a negative 1. So that means that where I have this I squared there, I can do a substitution of a negative 1. Now, in the meantime, I'm going to combine like terms, but I am going to have to do a substitution there as well. So I'm going to say 21. Well, 28i minus 6i, 28 minus 6 is a 22i, and then that negative 8 is going to stay, but where I have the I squared, I'm going to plug in a negative 1. Okay? And then what you're going to say is negative 8 times negative 1 is a positive 8. And then you're going to say 21 plus 8 is a 29. Okay. Now, once you get the hang of this, you just realize that wherever you see that I squared there, you're simply going to flip whatever the sign is in front of it and keep the coefficient. That pattern is going to be persisting, right? But this is why, algebraically. But once you get the hang of it, you can just flip the sign. So once I see that, oh, it's negative 8i squared, you go, oh, it's positive 8. So you kind of go straight from there to that, just recognizing this, just flip the sign, and the I squared is going to disappear. And that's true.